So we're still working on our 5-step program, except now we're going to do step 5 of our 5-step program. We're actually going to solve the stuff, right? So let's go ahead and see if you can set up all the equations for EX2. Now, before you even get started to setting up equations and things, why can't you just, is HCl, Erica, a strong acid? Right? So why can't we just take P, right, the negative log of 7 times 10 to the negative 8? Right? Why not? It's a strong acid. Does anyone see what the problem is?
Because of the interactions of the hydrogen with water,
Oh, you're getting close. What is the P? If you have this nice pure water at 25 degrees Celsius, what is the normal? Does water fall apart to H plus and OH minus naturally? Yeah, it's called autoionization or autoprotolysis, right? Okay, and Kw is what number? 1 times 10 to the negative 14. Now, hang on to that number, Nyla. So that means the concentration of H and the concentration of OH must be equal to what number then? 1 times 10 to the negative 1 times 10 to the negative 14 has to equal x squared. So x would be, take the square root, 10 to the negative 7. Now Nihilus can say it. The concentration of H is 1 times 10 to the negative 7. Concentration of OH is 1 times 10 to the negative 7. You know, in a pure water solution at 25 degrees Celsius. And that's just from autoprotolysis of water. So we're trying to say that if you say the pH is 7 times 10, you know, the negative log of 7 to 10 to the negative 8, you're saying that's what the concentration of H is. But there's more than one source of H. Usually we could forget about the autoprotolysis of water. 10 to the negative 7? Come on, we calculate what's the pH of 0.1 molar HCl. Right? Take a negative log of 0.1. That's 1 times 10 to the negative 1. We're talking about 1,000,000 times smaller here. So the contribution due to water falling apart physically is actually contributing. So we have to take it into account. And that's why this is a systematic treatment of equilibrium problem. Simply because the concentration is so darn low. If it wasn't low, you could still do a full systematic treatment, but you're going to get the same answer. Right? Because 1 times 10 to the negative 7 is nothing in comparison to 0.2 molar or whatever it is. Okay? So go ahead and set this up. This is a real systematic treatment problem. To get the right answer, real life answer, you have to do full systematic treatment. So go ahead and see if you can follow the 5 steps and set up the equations, and then we'll see if we can solve it. There's no Ka for HCl. Oh. Change all these to 18. Copy our steps. And when you're done, hopefully you have. We're going all the way to, we're going to solve, yep. All these problems today we're going to solve. And what we don't get done in class will be homework. So let's see if we can knock out as many as we can here. Okay. Let's see how far you got here. Pablo, what are all your pertinent species? H plus, Cl minus. And now you don't really have to write OH minus here, but once you start writing Kw, you're going to see I have to add OH minus to my list. So really, whenever you have an H plus, you're going to have OH minus. But if you don't want to, you can skip it. But then once you get to step 2, you realize you have to write KW. So might as well add it right away. But you don't have to. Are there any other pertinent species? Jeff, is that it? That's it. Good. Okay, so now Adriana, what's step 2? What equation did you write, or any equation? KW, good. 1 times 10 to the negative 14 equals hydrogen times hydroxide. Okay. Now, Miriam, we can get lucky. Do we have Do we have enough equations to match the unknowns? No. No. No, we got to keep going, right? Okay, so let's keep going. Pedro, we need another equation then. So now we did everything we could in step 2, so step 3. What would you write for step 3? Okay, so what would you write? Okay, so hydrogen over here, and then what? Times or plus? All right, good. All the pluses on one side, minuses on the other. Okay, Kat, I still see we're shortening the equation, right? 1, 2, 3, so.
7.0 times 10 to the negative 8.
That's because we did everything we could with charge balance, so we got to be playing with mass balance, and that's going to be something with this. I think you're right. What equation can we write? 7. Well, no KSP. Now, you can add more English to this. You can say that 7 times 10 to the negative 8, well, jump up here. 7 times 10 to the negative 8 equals chloride in all its forms. So you write chloride, then you look and see if there's any other forms for chloride, and there isn't. Now, you could also say 7 times 10 to the negative 8 is equal to H in all its forms. But there's a problem with that. Because H is also, because what is the solution in? Water, so yeah, it's kind of screwed there. You can't do much with H. So, but we're done. We don't care about H because look, 3 unknowns, 3 equations. Okay. So let's see if Natalie remembers how to do this. What would you do first? There's a lot of different ways to handle this, but we got to do something. We could plug this guy in, right? That way someone's saying plug in. That way at least we'll get rid of one unknown up here, right? So he's 7 times 10 to the negative 8. Kind of a cheesy way to plug in, but... Okay, Jamesa, now what? Okay, do what? Mess with the KW equation and solve for what? Solve for the H. Fine. See, it doesn't really matter. Right, solve for the H, and then substitute in over here, right? So if you want, sometimes they did stuff like this. Sometimes it makes it easier, right? You say rearrange. You don't have to do this, but it's a lot easier to follow if you're trying to show somebody what you did, right? So rearrange 1. So she said solve for H, so we're going to solve for H. And that's just 1 times 10 to the negative 14 all over OH, right? And then you get, I don't know, I guess this is a new equation, so you call it 4, right? And then you can, the English you don't need to worry about. If you don't want to do this, don't. Substitute 4 into, which equation? 3. So if you don't want to do that, don't worry about it. Okay, so wherever we see an H plus, we're going to substitute that in. So we'll have 1 times 10 to the negative 14 all over OH equals 7 times 10 to the negative 8 plus OH. Okay. It's looking better, Miranda. Now what? Multiply through by OH, because what's the name of the equation you're going to end up with? Quadratic. Right? Okay, so multiply through by OH. So we'll have 1 times 10 to the negative 14 equals 7 times 10 to the negative 8 times OH plus OH squared. Okay, so let's get it in that format of the quadratic equation. Oh yeah, yeah. Oh yeah. If you do something like that, though, you really need to write some English. Say, let x equal, and then there's no problem there. A lot less writing, that's for sure. Okay, so let's get it in the format of, Casey, what's that format of the quadratic equation? What format are we trying to get it into? Yeah, what times x squared, though? Remember, it was ax squared plus ax squared plus bx plus, what case? C. All that has to equal 0, right? And then if you do that, if you know how to use your calculator, you don't need this next part. But if you do know how to use your calculator, you don't need this little equation. But if you don't know how to use your calculator, you're going to have to use this. Right? Okay, so let's get it in the right format here. I think we're all going to get stuck. Even I don't think this guy can do quadratic. All right, so let's get it in the right format here. We need 0 equals concentration of OH minus. Now, I see how I could have brought OH minus squared to this side, but then it has a negative out front. It seems like we're used to having just a 1 for our A all the time. That's how I did it a lot. So I like to have just a 1 for the A. I guess it's less writing, too. Right? So hydroxide squared plus 7 times 10 to the negative 8 OH minus 1 times 10 to the negative 14. Okay, so now you know what your A and your B and your C are. You recognize C's negative. Plug him in. See what you get. And I'm going to have to write stuff down, otherwise I'm not going to remember what the heck I'm doing. B squared. Now you need to carry a bunch of digits when you do this kind of stuff. 2.119 or something. Okay. And since we're solving for a concentration, we can't get a negative concentration. So I wouldn't even mess with the 7 times 10 to the negative 8 minus that number, because you can't have negative concentrations. 7.095 times 10 to the negative 8. Okay, 7.095 times 10 to the negative 8. Did you get that? That's my OH. Did anybody else get that? I don't want to keep going because I may have screwed up. Anybody else get that? B squared minus 4AC. Kimberly, did you get this? So did you guys get this number for the square root part? Okay. So this part, someone verify got the same as me. Pedro did.
That's for the square part?
That is what's in the square root part.
Oh, that's that. Oh, okay.
Yeah, you gotta take b squared minus 4ac, whatever you get, take the square root. And don't forget to divide by 2. You did? Okay, good. Pablo got this. So that's 2 of us got it, so I bet you that's... Okay. A lot of folks are getting it. Make sure you can get it. So now you know what this is. Go find out what the rest of them are. I think there's only one left, and that's H+, because chloride we know. And does it matter which equation you use? No. There's no sense of time in any of this. All these equations are valid simultaneously. They're all equally valid. So whichever one is the easiest to get H+, that's the one you should use. And I don't know about the equally complicated. So use one of them, and you're going to get the exact same answer for H+. Heck, I could just use... What is it? C is negative, so that's going to cancel out that negative. You end up adding.
Oh, that's what I see.
Okay, so this is the concentration of H. If we would have said, see, that's a huge difference. 7 times 10 to the negative 8 versus 1.4 times 10 to the negative 7. That's huge, right? I mean, and pH is an extremely important measurement. So that affects so many things, from syntheses to life itself. So full systematic treatment was a big deal for this guy. Oh, I should have big M's here, otherwise I'd take points off. Okay? Probably. I mean, your calculator's so big, if it can't do it, I would be really upset. Okay, now be careful. If you're I'm just worried about the word trace, because I can see homework questions, quiz questions, and those coming up saying this way. I can see the question right now because I was ready to write it. Find the pH of 7 times 10 to the negative 8 molar with and without systematic treatment of equilibrium, and give the pH to the thousandths place or something. So if your little trace thing won't give it to whatever place we're asking for, then you're out of luck. That's my only worry about trace. Okay. And I don't know. I don't know. I know this works. Let's try to set up another one here. Use a systematic treatment of equilibrium to determine the concentrations of all species present in A's. So where's A? Here's A. That's A. What the heck is there to do there? Right? Oh, I think A is A all of these? Yeah, there's nothing really to do there. I think no. When it says A, it's referring to all of these. Isn't it? Oh, really? Why would I even ask that? There's nothing to do. Oh, okay, fine. Okay, what's EX4? It's present in B. All right, well, let's do B then. B had better be somewhat complicated here. Oh, yeah, right. No, this is present in, sorry. This is supposed to be EX. EX, what is this? EX1. That's what it's supposed to say. It's a typo. All right, and you're right, a lot of these aren't going to be really quick. They won't be that bad at all. So you go back up and you find out what you did for these. Here they are. Here's our work. So a lot of these aren't going to be too bad at all. But the other ones will be a little bit more work. So let's work together on them to see if we can knock them out. And what we don't get done, you might get a lot of it done here. You've got a half hour, so, well, 20 minutes. So we can knock out as much as you can. Because the leftover is homework, so see if you can get it done. So we're solving for everything we've set up. F is going to be F. We are not going to include in this. All right, let's do F. We'll set it up, but let's say not including F. My gosh, that would be. I'm mean, but I'm not that mean. Not including F.
Until the test comes around, you're like, do F.
Yeah. All right. K2CO3. The problem with K2CO3 is you can write Ka1 and Ka2.
Right.
So you're going to have all those species.
Okay, yes. Okay.
Yeah.
I like how that.
You're right. So work on this. If you want me to help you with F or help any of these, just let me know. No, there's a whole new question. So find. So you've set all these up, and now you want to solve them all, except for this one. We're not going to solve this one.
So just do the math.
Yeah.
that's cheating.